Okay, so this is lecture 2.2 going over the review of atomic structure. So if you are watching this for an absence, make sure that you pause it to answer the bell work. If not, let's go ahead and go get started. So the agenda, again, if you're absent, we have our lecture. You're going to start your inquiry based, and then you get to individual practice problems. So after D, you're going to be able to find the atomic mass, atomic number, and symbols of elements off of the periodic table. And given the atomic number and the mass number of an atom, state the number of protons, neutrons, and electrons. So review, let me get my pen. So review of the subatomic particles in an atom. So an atom is made up of, at our level, protons, neutrons, and electrons. There's also things called quarks and other things else, but for us, we just need to know those three is subatomic. So the symbol of a proton is P with a little positive sign right here. So that's because a proton is positive. So lots of times when you see a proton symbol, you'll just see it as positive. And that's because scientists are lazy and we don't like writing 1, but it's actually positive 1. The relative mass, it's what's known as 1 atomic mass unit, so AMU. And the location is the nucleus. The proton is responsible for the atom's identity. So, for example, all hydrogen atoms will have a proton of 1 every single time, no matter what. They'll all have an identity of 1. And it's also responsible for the mass. A neutron, the symbol for a neutron is N with a little 0 right here because a neutron has a charge of 0. So lots of times you'll see me write zeros like this because that differentiates it from it being an O for oxygen. It has a mass of 1 AMU, so 1 atomic mass unit. Its location is in the nucleus, and its responsibility is mass. So what this means is that all the mass of the element is located in the nucleus. So the nucleus is where we have mass. The electron is E with a little negative sign because electrons are negative. Their charge is -1. They have what's known as a negligible mass. So the mass is so small that it doesn't really matter. They do have a mass, but again, it's so small that it's just not worth it to calculate it. So we normally say it's a mass of 0. Its location, so right, is on the outside, which is also known as the electron cloud, energy level, rings, and orbitals. So we'll just call it the electron cloud. It's responsible for the reactivity / charge of an atom. Okay. So we have two things that you might not know, but you might know. So for example, the first one is the atomic number. The atomic number is the number of protons in an element. An atomic number is found normally at the top, though sometimes it'll be on like the square right here. So the atomic number of hydrogen is 1, so that means we have 1 proton and a hydrogen. And for example, levinium all the way down here, the atomic number is 116, so its protons is 116. So what this means, again, if you change the protons, you change what the element is every single time. The protons give an atom its identity. The protons give an atom its identity. The mass number, The mass number is a whole number, and it's all the mass that's in a nucleus, meaning that the mass is protons plus neutrons. Now, if you look at your periodic table, you'll notice that the mass on the periodic table is averaged. So lots of times if I ask you for the mass number, I'm asking you of a specific element, well, how many neutrons does this one hydrogen atom have? How many neutrons does this one lithium atom have? Versus what's the mass of all the lithium atoms that we know of? So in summary, atomic number is protons, and in a neutral atom, that means it has no charge, it equals electrons. The mass number is protons plus neutrons, and neutrons, to get neutrons, you do mass minus atomic number. So tying it all together, this is what's known as shorthand or isotopic notation. And right here, messed up. Charge is equal to protons minus electrons. Okay, so if you notice there's a really big whole number right here, this is a mass number, because remember the mass is protons and neutrons adding together. Down here is the protons, which is the atomic number, and over here tells you the change in electrons. So if you notice that an atom has a charge, that tells you that protons do not equal electrons. Now to find neutrons, it's just mass minus protons, so 41 minus 20, which is 21. So we're going to tie it all together and fill out this chart. Now I'll be going back and forth. There is a periodic table. You'll always have a periodic table. So there we go. The first number I come across is zinc. So I need to know the atomic number of zinc because every single zinc will have the same atomic number. And if I look, zinc is right here. It's atomic number 30. Okay, so it's atomic number 30, and that's really all I need to know from the periodic table. So the atomic number is always equal to the number of protons. So that means I have 30 protons. And the next thing I know is the number of neutrons. So remember, mass is protons plus neutrons. So 66 minus 30 will give me 36. So now let's write shorthand notation. So the symbol for zinc from the periodic table is Zn. The mass goes on top. The mass is 66. The atomic number goes on bottom. The atomic number is 30. And last but not least, I need to see if I have a charge. If your protons equal your electrons, there's no charge, and that's because they cancel each other out. So I have 30 protons minus 30 electrons, because my electrons are negative, equals 0. So there's no charge, so don't write anything right there. And then, so this is what's known as zinc 66. And that is because I'm looking at a zinc atom that has a mass of 66. So the next thing we come across is 12, and so that's right here. Actually, let me erase that one little circle really fast. So since it's atomic number 12, that means it has to be 12 protons. And to find mass, mass is protons and neutrons, so I'm going to add them together. 12 plus 13 is 25. So that's the mass. The mass is just telling us how heavy it is. Remember, the identities is protons. So we're looking for element number 12. So element number 12 is magnesium. So its symbol is Mg. Now remember, the mass goes on top. The mass is heavy, so it's 25. And the identity, which is 12, goes on bottom. So I have 12 protons and 12 electrons. So I have no charge. So this is what's known as magnesium 25. So it's a magnesium atom with a mass of 25. So the next thing I come across, the next one is potassium. Oops, sorry, keep on coughing. So potassium, I look right here, potassium has an atomic number of 19. So atomic number 19. So every single time that tells us the number of protons, there's 19 protons. To find the mass, you add them together. So this is going to be a mass of 39 for this specific potassium atom. So it's potassium 39. And so it's going to be K, 39 on top, 19 down here. And then if I look, I have 19 protons minus 19 electrons, which equals 0. So this does not have a charge. Last one. So I see that has 16. I look at my periodic table. Element 16 is sulfur. So that's atomic number 16. The mass, protons plus neutrons, every single time you find the mass, is 31. So 31 goes up here. I have 16 protons minus 16 electrons equals 0, so there's no charge on this one. And it's what's known as sulfur 16. And guys, that's it for review of atomic structure. If you have any questions, please feel free to reach out or rewatch this video or look at your notes or anything else. Other than that, have a great day.